2. We're going to go probably for about 50 minutes today is my guess, okay? 50. I am right now, thank you. Okay, so today we're going to learn some like basic little tricks with derivatives. They're rules, but they're tricks. Okay? I want yellow. So, I like to call them tricks because they're not the whole formal limit definition. Everything we do, we could do with the formal limit definition of a derivative. All of these come from the formal limit definition of a derivative. So yes, these are tricks, but they are rules that we get from that. Then we're going to still deal with tangent lines. Okay, so now we're going to deal a little bit more with all of this with tangent lines. And then we're going to hopefully have a very firm foundation on average rate of change versus instantaneous rate of change. Oops. And tomorrow we're going to do a lot of that with position, velocity, acceleration. So we can go ahead and put it on there, but this is going to be tomorrow. So position, velocity, acceleration relationships. Are you guys okay that I pull it? That I don't write out? Okay. I should. Okay. I know. Okay. I'm such a bullet person. Position, velocity, acceleration. How many of you guys have taken physics? Okay. It definitely helps when we get to all these relationships, okay? Okay, so we're going to start with the basic rules, i.e. the tricks. So first is a constant. Give me a constant. What? 4. Give me another one.
Avogadro's number. 6.023 times 10.
Alright, good. 2. Pi. Okay, all of those are constants. Some of them are weird and I love it, but all of those are constants. For instance, the pi. I'm just going to use his. Sorry, I don't want to write out yours. Okay, so if I had this y equals pi, right? So pi is a constant. What's the slope of a constant? 0, no matter what the constant. So the derivative of any constant is 0. Bless you. Good? Okay. The next one we have is our power rule, and we were already discovering this. We said, hey, the degree goes down by what? 1 when we take the derivative. But not only does it go down by 1, but this little guy that was the power comes down in front, and then we subtract the 1. So if I had y equals x cubed, what does y prime become? Well, this goes down in front, and then I subtract the 1.
Oh yeah, he made us do everything.
Okay, now, hold on. On your test, you will have questions that state, use the formal limit definition of a derivative. And you have to. You can't use these tricks. If it doesn't state that, you get to use all of this.
How would we do something like x to the third plus x squared?
We're going to do that. We're getting there. Okay, we're getting there. Okay. Then we have this coefficient. So when I have a coefficient, I'm going to think of this little monkey guy. Okay, not monkey, monk guy. Okay, monk, monk. Okay, so I'm going to think of this little monk on a roller coaster. I don't know why I always think of this. Every time I see a coefficient, I love this picture. Actually, I think I like his face. Okay, so what are they doing? They're going along for the ride. Okay, so when you see this coefficient, coefficients get to do what? Woohoo! Go along for the ride. Okay, that's going to be true. And so when I get all excited and you ask me a question, I'll be like, what does that coefficient do? You'll be like, woohoo! Going along for the ride. Yes. Okay. So, if I put a 4 out in front, that's a coefficient. So what does that 4 do? Goes along for the ride. Okay. So this would end up being 12. The other thing is the sum or difference. When I have a plus or a minus, I can think of those as just separated. So if I also had now plus let's just do plus x to the 5th. Then now I can just plus the derivative of x to the 5th. The 5 comes down. I subtract 1. So you can do plus and minuses separately. Now, this is a big deal. You can not do division or multiplication separately. These are rules. We were not going to get to them today, but we will get to them. 2.1. Maybe 2.1. And then one more thing before we go on to the little tricky ones. If I have, let's say I had plus 5x, okay? 5x, think of the graph of 5x. What is the slope no matter what? 5. Okay? So when you just have x to the first, it just becomes whatever the coefficient is. It's just the slope. It's linear. So the line with a non-zero slope goes to a line with a 0 slope, like y equals 5. Okay? So that one sometimes gets tricky. And you can do the power rule. Think 1 goes down in front, right? So if I put the 1 down in front, then now I have x to the 0. X to the 0 is just 1. So I'm just left with 5. And then the other two that you need to memorize for now, we're going to get more trick, are sine and cosine. You just need to know these. Derivative of sine is cosine. Derivative of cosine is negative sine. And we're going to make a little note. Anytime I take the derivatives with a c for the trig, they come out negative. So give yourself a note. Derivatives with trig c's come out negative. So will the derivative of tan come out negative? No. Will the derivative of cosecant come out negative? Yes. Will the derivative of secant come out negative? No. Secant is s. Yeah. So the derivatives that start with c come out negative. It's just a little mnemonic device to help. but sine and cosine are each other basically with the negative from the sine, or from the cosine to the sine. Okay? So questions so far about those rules? Group leaders, have somebody tell you the difference between a constant and a coefficient. Go.
Different constant coefficient. Coefficient.
All right. Okay, refocus. We're going to look at number 1. Are all of these guys plus or minus? So can I do them each separately? Yes. So as I go to do the first one, well, first off, f becomes now f prime when I go to take the derivative. A lot of you will just go right into the 30x squared. A lot of you will do that because you said, hey, 10 goes along for the ride, the 3 comes down, and I subtract 1 from the exponent. So most of you will start just saying 30x squared, boom. Okay? And that is fine. You don't need to show me every little minute step. Okay, keep going. Okay, is the derivative of the 10x cubed okay? Questions on that? Derivative of 7x squared. Questions on that? Derivative of negative x. Questions on that? Derivative of 19. Question on that? 19 is a constant, right? It's just a number. So think that's like y equals 19. It's a horizontal line. What's the slope of that? 0. So we get out our 0. Okay, questions on the last one. You bring your negative 2/3 down in front, and then you subtract 1. Negative 2/3 minus 1 is negative 5/3. Okay. Good? All right. Let's look at number 2. What's wrong with number 2? It's got division. Gosh, dang it. We don't have a rule for division. Well, we can use some algebra skills to get rid of the division. Yeah, so we're basically just going to distribute this guy into all 3. Divide, divide, divide. Or multiply through by 1 over s squared. multiply by s to the negative 2. However you want to think of it. So first we're just going to rewrite so that we can apply our rules. And even when we learn the division rule, it's going to be much easier to rewrite and do the rule. Would you rewrite it like that? Have we done any calculus yet? No. No derivatives, no calculus, all pre-calc so far. So 1 over s squared is s to the negative 2. Okay. Now can we do our calculus?
Yes.
Yes. Yeah. Go. See how calculus isn't always the hard part. How'd you do? That's fine. I don't care. Chloe? Because we bring this guy down in front and then subtract 1. Now, on a multiple choice test, you may have to match it to go back to original format. The original format didn't have negative exponents. It had like poly over poly, a rational expression, right? So could you now get this back to a poly over a poly? If it's a free response, you're done. But let's go ahead and see if we can get this back to now a poly over a poly, rational expression. Poly, poly? Good?
Okay. That makes sense.
So that may be what you have to match it to for a multiple choice question.
What did you just, since the S,
Shh,
the
guys.
left is, S, or it's 2S, the negative third exponent, why didn't you use even?
Huh?
If it's S, negative 3.
I did that first, so there's multiple ways. So we could say this. Did anybody say I could factor out the 2s to the negative 3? So this would be 2s to the 4th minus 1, right? So that's like 2s to the 4th minus 1 all over s cubed. Same thing. 4 got erased. Okay, so lots of ways. All that's pre-calc. Okay, number 3. Oh man, it's division again. Oh, wait, I can rewrite this. Okay, try number 3. Rewrite it.
Rewrite it. X to the third.
write it correctly.
Oh, yes, it is.
Now do the calculus.
Oh, because you put
No, negative.
and then you just said do calculus. Constants of pi.
Let's come back to the original format in case that's how they want it.
Minus 1.
What? Oh, that's an X. Oh my gosh.
Yeah, that was
Thanks.
barely.
Thanks, Evan. Oh. I will do what I have to do. I wasn't trying to trick you.
You can totally just teach yourself alcohol.
I think you're right.
No, don't ever.
What's the first sentence?
That's a 5. Okay. So are we good? So far, so good? Questions? Alright. 2 more basic rules, and then we're going to move on to something else. So let's see if we can get these 2 basic rules down. First, I need to do what with number 4?
Rewrite it.
Rewrite it. Okay, did you rewrite it like that? How did you rewrite it?
Oh,
How do you get my coefficient out in front, right?
so you squared it.
So I had to get that 3 taken out from the t part. I need the coefficient out in front. Mhm. And then there was t squared in the denominator. So I brought it up to be in my numerator. Pre-calc so far. Don't you love it when I say that to you? And now we're going to do the calculus part. See if you get it. Don't write what I write. That's the worst thing you can do.
We distribute the negative to bottom and top, right? Just the top.
So I bring my 2 down, subtract 1, so I'm at -3.
Just the numerator.
So that I can bring the exponent, like I can bring the t down.
Trust you. Let me look. Let's teeth.
So I would guess your step would show pi over 9 times -2t to the -3. So then this would be -2 pi over 9 t to the -3. So then this would be -2 pi 9 t to the 3rd. Okay?
Key to success.
me. I got a little typo. Oh, did we skip one? Hold on. Oh no, I kept writing. All right.
Hey,
No, you'll want the practice. I mean, you're gonna have to know it. Okay. It's not bad. Pi over 3 is a what? What does it get to do? Along for the ride. Cosine is a c, so the derivative becomes negative, and it goes to sine. Now, before you move on, I want you to look at what I write. What if I wrote this? Is that correct? Because now it looks like it's a minus, even if I had this. Is that correct? No. So be careful with that negative. Put it out in front. Make sure you're multiplying. Okay, 4 is a coefficient. It gets to go along for the ride. Derivative of sine goes to, does it go to a negative? No, because sine was s. And then this last one, it's kind of like saying minus 2x, right? It's just a line with a weird slope of negative 2. Oh, this is negative radical 2. So it just, the derivative goes to, no, not a constant. Yeah, negative radical 2. Rod? It was not. The variable was not in the radical. That radical is 2. Mm-hmm. Yeah. All right. So now on this one, fix it. The point was wrong. It should say negative 1, comma 108. I don't know what I did. Okay. So now we want to find the equation of a tangent line. We do not have to do the formal limit process unless it says. Does it say? No. So I have this f of x, and I know I still need to do what to the f of x? Find the derivative to get the slope. Okay. Can I do my power rule here? No. So what do I first need to do? Rewrite it. Foil your plan, okay? And then distribute your 3. Rewrite it first. Do your pre-calculus.
So that's try to do it from this. It's the same.
Still good?
Yes. 3 point swish.
Alright. So all we did was rewrite f of x. We haven't done anything really for this problem. Now go find the equation of the tangent line. Go.
Yeah, no, she's. You should always pay attention to her. You can see her. Keep on going. Right. 180.
So you guys, look at your neighbor and help me out here because I'm kind of trying to look. I'm seeing a few people that don't have it. Make sure that they have these guys labeled. If all they have is this, tell them it's going to hurt them in the long run not to do that. Tell them to go label. Look at your neighbor and look.
You better.
Do you get counted off the test if you did it?
No, but it's going to hurt you
Yeah.
because you're not going to know what's what, and you're going to have then multiple derivatives and different things, and you'll get lost.
Blow up.
Okay, so is everybody good on that? Any questions? They're so chatty today. I know. Normally I don't mind as much, but it's hard to talk over you today, that's all. I've been really sick, so. Okay. I like that you're talking, and I hear lots of good conversations, so yeah.
Might be because the Chiefs are playing the Patriots.
No, that has nothing to do with the
Colin, who even cares about the Chiefs?
Gosh.
They are going to lose. Whoa.
Hey, hey.
Whoa, whoa.
Gotta have some.
Watch it. Watch it.
They're actually great.
You were like the only person not talking, and now you need to continue that pattern. Okay, let's okay. Let's go to this one. Again, you had fun like this, and now do you think you could do it? Let's see if you can do it in 1 minute with your group. Go.
Okay, what's it?
So, point of 2, 3. No, so you do the point slow. It's negative 1/5.
Yeah.
Minus 2.
30 seconds.
Ooh.
Multiply it.
That's 1/5. Yeah.
Yeah.
No, 0.2.
It double. It'd be 0.2.
No,
I just did it in 15 seconds. I'm done.
Okay.
no, yeah, but
5, 4, 3, 2, 1. Okay. Let me tell you why I was able to do it so fast. First off, the information was given, so I just had to get to my tangent line, right? So we know this is dealing with the slope, and this is my point slope. Then I want to plug in 1.9 into the x. So I plugged 1.9 in, and all I did was add over my 3. On the AP test, you guys are going to love this. You don't have to simplify this. Anything that's numerical, you get to leave. And in fact, I encourage you to leave it to save your time, okay? AP test is not here to see if you can do pre-algebra. AP test is here to see if you got the concepts. Okay, so you can leave that on my test as well. Now, if it's a multiple choice, are you going to have to go work it out and see what the answer is? Sure. Okay? You want a little extension really quick?
No.
I know you do. I saw lots of heads saying, yeah, this is nice. I appreciate all your conceptual understanding. Okay. So, what if I told you f double prime of 2 now is, give me a number, any number.
4.
You know what, I want to hear from Ariana. approximation, an over or an under estimate. Okay? And this is what we're going to start learning. Remember how we talked about concavity yesterday? Okay. When the second derivative is positive, it's telling me that I am concave up, shaped like a calc. That's what this piece of information would give me in all of that blob. It's usually like a part B or something, right? So if I am concave up right there, then all of the linear things are what? Under estimates or under approximations. There's a little extra for you today. Now you've seen it, you'll see it again in the future. You got some pre-knowledge. I'm telling you right now. When the second derivative, when this guy is positive, then F is concave up.
If it's negative, then it's
Then
down.
F is concave down. Yeah, we shouldn't say it, should we? F is concave. Okay, so that was your little extra for today. Okay, last concept that we're going to deal with. The average rate of change versus instantaneous rate of change. And you guys, we've talked about this, we're going to hit it one more time. And then tomorrow we're going to apply it with position velocity acceleration. Even more. Okay, so let's say that I have this graph, and I'm going to draw the same graph. I have this instantaneous. Yeah, I'm going to draw the same graph here as I did here. Oh, man. What did mine look like? Okay. Gosh, dang it. Okay. Let me just redo it. Oh, well, okay. I don't know why it's being so picky. Alright, so I'm drawing the same graph. And now let's say that I have some point A, some point B. And then I have a C in the middle. Okay? Again, I have some point A, some point B with a C in the middle. And let's say that this is my position function going on, f of t. And give me a label for time, any label for time. Minutes, I heard. And give me a label for distance. Meters. Okay, so we just picked it for some, whatever, okay? So the position is changing in meters with respect to time going on in my graph, right? So when time is B, I am here in meters, right? But let's say that I went now and I found the slope of this line. What is the slope of this line? Okay, but more in general, it is f of what? Okay, nope, it's not a prime because it's a secant line. So it's like f of b minus f of a over b minus a, where this position is my function f. Okay, so this is f of x. So the slope here, have you seen this over and over and over and over and over? This is just the change in y, or the change in position, over the change in x, or the change in time here. How would I label that? extra hump on that end, but whatever. Okay. So I'm going to get this average rate of change, meaning I'm seeing from this interval of A to B what the rate of change is in meters per minute. So when I see average, all that means is that you're on some interval. Okay? That's all. Just meaning, hey, from this value to this value, this is what's going on. Now on my other graph, let's do the same thing. We said that this is the position of, we're going to call it an f of x. We did minutes and we did meters. And now let's talk about that instantaneous here at C. I use the same colors. Blue. So it just barely taps. It's that instantaneous. What is the slope of this guy? Do I do change in y over change of x? No. In this, I do the f prime, okay, of, well, in this case, c for this particular one. F prime of x is the slope of all of them. F prime of c is the slope of that one, right? Is this still a change in position over a change in time? Yeah, it's just the instantaneous change in position over time. So how do I label this guy? Still meters per minute. So even though here I deal with derivatives, and here I don't deal with derivatives, they're still giving me the same rate of change. Just one is instantaneous and one is average. Okay? So just because we're seeing rate of change, we don't need to take derivatives. Only when it is the instantaneous. And our labeling is still going to be the same. So on this one, if it wants me to find the average rate of change here, can we do that? F of 5 minus f of 2 over 5 minus 2. No derivatives, right? Just plain old slope for average rate of change. Can I leave this as an answer? No, because I have the f's. Use calculators for time purposes right now. What is f of 5? What's f of 2? Huh? 7 over 3. Could I leave that as my answer? Yes. It does. Okay, I could leave that as my answer, but for now we're going to go ahead and reduce. What is it?
38.
38. So if it was, again, minutes and meters, I would label this minutes per meter kind of thing. Sorry, meters per minute kind of thing, right? So the labeling would still be the same. But now let's go say, and I don't want to do end to end points, let's just say at some point in between there. Pick a point in between there.
2.5.
Okay, okay, I like 3 or 4 better. I don't want to, okay. So when I'm here, now I want to find that instantaneous at one specific value. So instantaneous is one value you're plugging in. Average is 2 values you're plugging in. So what do I do to find that instantaneous? Well, yeah, but we have tricks now. So we can take our derivative. we get out 26. And again, my labeling, if it was what we had from above, it would still be meters per minute, right? Okay, so graphically, if I'm going to go look at that like graph, if it looks something like this, I had 2, 3, and 5. So 2 to 5 gave me some slope that was 38, and at 3, I had some slope that was 26. That's all. Okay? One is just the average between two values, and one is directly at one value. And that's where we're going to pause today.